Welcome back, physical geology students. We were talking about earthquakes, and I believe we left off on this slide. It's called the causes of earthquakes, and we were talking about the elastic rebound theory. And I kind of went through each of these little block diagrams here. I'll kind of review. So first of all, we were talking about basically stress and strain. And when we apply a given stress, let's say I have my coffee cup, and we apply a stress to this coffee cup, the result is we're putting a strain on this cup as well. And rocks can only can hold so much strain until they reach a limit, and then they rupture. And that rupture is the energy that's released in the form of seismic waves. And I was talking about that there were primary waves we'll talk about, and then secondary waves or shear waves. But here, essentially a fault, this is showing a fault that's cutting through the block, and it's just a fault plane. There hasn't been any stress applied. And then here this is showing the block with the fault, but however here we have stress being applied here, and then we have stress being applied over here. Now, what's happening is we're building up strain in these rocks. And again, like I said, at a certain point, they're going to release this energy, or the strain is released, and then they rupture, and then you create an earthquake. And in the third diagram block here, that's what that's showing. Here, there was a point where it ruptured, and it's released, the strain is released, and then we have an earthquake. So I hope that that helped, kind of that summary, and we'll move on to the next slide. So here's kind of this is just an animation showing here, showing how elastic rebound theory works. Let's see here. Oh, there it is. So it's showing here basically it bend a little bit, and it's at a point where it reaches a critical kind of limit, and then it ruptures, and then we get our earthquake. So rocks can only hold so much strain until they rupture, when they do rupture, it's going to be brittle type deformation. So that's kind of that there. So here, now we're going to talk about seismic waves. So these are the waves that are created from, once that strain is released, you're going to create different types of waves. And these are called seismic waves. And so on this diagram here, I want to kind of point out certain features that are important. So we have, typically on the news or on the radio, you're going to hear when they kind of report an earthquake, typically on the surface of the earth, that's what they reference. They're going to be referencing the epicenter, which is the point on the surface, and then right below, in the earth, is called the focus, and that's the kind of the rupture point, or where on that fault, essentially when that fault ruptured, that's called the focus. So again, seismic waves travel along, typically along the faults, and there's two types. There's going to be you have the surface waves, and then you have the body waves. And these are the body waves are the ones that propagate through the interior of the earth. So here's just another block diagram showing, again, the fault here, and then we have the focus. That's the point of rupture, and then right above that we have the epicenter. So you can kind of see here these kind of waves kind of propagating, kind of the crest, kind of this wave propagating through the earth, showing that. Whoop. So there's going to be two types of waves, body waves. One, there's these primary waves, and these are the fastest ones, and they travel both through liquid and rock. Then there's the secondary waves, or the shear waves. These are slower than the P waves, and they do not travel through liquids. And it's just showing here this block diagram showing if you have a slinky down here, if you were to kind of take that slinky and push it like that, what happens is that wave is going to compress the rock, and then it's going to expand it, and then it's going to compress the rock, and then expand it again. On the other hand, these secondary shear waves, when these guys form, they're showing a hammer if you were to hit here. So essentially this wave is going to be perpendicular to it's the rock body. So it's going to flow like this. It'll create, and I'll show you on the next slide in more detail if you can't see that here. So here's kind of the same, but in kind of closer up, just showing an undisturbed rock body. And then here we have a primary wave here, and it's just showing once we initiate that energy, we're going to have an area where the rock is compressed, expand, compressed, and then we have this undisturbed point. And then here, the shear wave, it's just showing here that it goes up and down. So you're going to have your kind of the crest of your wave, and then you're going to have your trough and your crest. And then it's just showing here, it looks like a secondary wave, and then the focus, and then the surface here. So here are some P waves, just showing this in more detail, showing if you can try this at home with a slinky, if you've got one, but you can attach it with a little eye hook on the wall, and you can actually move your, kind of just push a little on the slinky, and you can actually see the slinky in areas, it'll compress, and then in areas it'll expand, and you can kind of see that. And this is showing it right here. And then once the wave hits the wall, it'll come back and retract. So here's just showing up close when you kind of take the rope and you kind of move it up and down, you're going to create a wave in the rope. And these are slower than the primary wave. So there's several other types of waves. They're more of they're secondary, but they're the surface wave, and then we have this Rayleigh wave. But the two main ones that you guys need to focus on are the primary wave with compressional, and then the shear wave or the secondary wave. Those are the two that you're going to need. In your laboratory exercise, you're going to have to actually triangulate the epicenter of an earthquake, which is really cool. So here's a seismograph. So this is the device that they use. It's very sensitive, and it actually they have one at the University of Wisconsin-Milwaukee where it's located down in the basement. But what they did was they had to build this huge rock column, and they put that rock column underneath, and they had to drill into the earth and then place it underneath the building so it can pick up any type of tremors or any types of movement, so it's undisturbed as well, and that's why they did that. But this is one more on a platform here, and it basically detects ground motion, and it records wave patterns of earthquakes. So this is a seismogram, is the actual, these are here's the seismogram. So this is the actual kind of results from it, and it's kind of showing this kind of seesaw kind of effect on the paper. But these are actually your P and your S waves, and you'll see that in the next slide. So here's how seismographs work. It's just showing you here. It's showing that it's basically suspended from a cable. It has this suspended mass, and it has this little metal pen marker that is on this rotating drum here. And this is mounted here to the bedrock. And essentially, when there's any ground motion, it essentially detects it, and it starts to move. And this rotating drum rotates counterclockwise. So here's kind of an example of a suspended cable with a mass on it. So any types of motions can be detected, and then that's basically written on this drum here. So here's what you need to do on your laboratory is you have to differentiate between your primary waves, your secondary wave, and then your surface waves. So the first that's going to arrive at the seismograph station is going to be your primary waves. And then later on, you'll have your S waves or your shear waves come. And then after that, you have usually your surface waves. So this is kind of some of the results from a hypothetical earthquake. So this here is showing you how to locate earthquakes. And what I'll do is I'll stop here and then I'll come back and we'll talk more about this. Okay, talk to you soon.